So right now you should be very confident using the limit definition. So this one too, we have 7 questions that I want us to go through. This is spring 2025. Now the first question is asking us to use the limit definition. And as I said, for us to use the limit definition first, we need to try to differentiate the function. So let's try and find f prime of x using the power rule here. This is going to give us 6x plus 5. So this is what we are going to work towards. This is what you are going to work towards. So now let's write the limit definition down. So f prime of x is equal to limit as h is approaching 0, f of x plus h minus f of x divided by h. So this is what you are going to get. Then now we have our f of x, so we need f of x plus h. But I'm going to write the f of x again so that I can show you the strategy here. So this is in the parentheses, so I'm going to put all the x in parentheses. So I can write this one as 3x squared plus 5x. So since now this is x, this is x, this is x in parentheses, I'm going to replace all the x's by x plus h. So it's going to give us f of x plus h, replace here. I need to replace this one by x plus h, replace this one too by x plus h. So 3x plus h plus 5x plus h. Because as soon as you get this one wrong, it means that everything that you are going to do will be wrong too. So that is very important to, get this one right. So now let's try and expand this. This is the same as 3x plus h, x plus h, plus distribute the 5 and get 5x plus 5h. This is the same as 3 times x squared plus 2xh plus h squared. This is h, then plus 5x plus 5h. This is 3x squared plus 6x h plus 3h squared plus 5x plus 5h. So now that we are done finding this, can we simplify? No, we cannot simplify anything here. So what I'm going to do is I'm going to look for f of x plus h minus f of x. So let's do that. F of x plus h minus f of x is equal to 3x squared plus 6x plus 3h squared plus 5x plus 5h minus. So as soon as I write the minus, I need to make use of the parentheses. Minus f of x is equal to this. So I'm going to have 3x squared plus 5x. So writing this is going to help you to simplify the function before you put it here, right? So it's very simple for us to do that. So now this is going to give us 3x squared plus 6xh plus 3h squared plus 5x plus 5h. Distribute the minus through and have 3x squared minus 5x. So now this will cancel this, and then this one too will cancel this. So as I said, as soon as you are finding for this and you do the cancellation, all the terms left should have h. So if you don't have h in that, then it means that you are getting something wrong. So this is xh plus squared plus 5h. So you see that every term here is involved with h. So now I can factor h out and have 6x plus 3h plus 5. Good. So now I was able to find this. So now I can write the formula here to finish the thing that we're doing. So now f prime of x is equal to limit h is approaching 0. Now this f of x plus h minus f of x is equal to this. So I'm going to have it here. h 6x plus 3h plus 5 divided by h. So that's what I just did. So this was this, which was simplified to this. So I just write it and divide by h. So that now h will cancel the h. Then I have the freedom to write this one as limit h is approaching 0, 6x plus 3h plus 5. Then I'm going to set 8 to 0 and have 6x plus 3 times 0 plus 5. And this is going to give us 6x plus 5. And we can see that 6x plus 5 is here. So this confirms that we didn't do any mistake in our calculation, so we don't need to go through the process again to check if we have something wrong or not. So this is question 1. Now let's look at question 2. Question 2 is all about taking derivatives. So what I'm going to do here is I'm going to say that this is equal to AB. Then if this is equal to AB, then I'll choose my A to be 2x squared and my B to be equal to sine x. So if I do that, A prime will be equal to 4x, and then B prime will be equal to, when I differentiate sine, I'm going to get cos, so I'm going to have cos of x. So multiply this by this and multiply this by this. So our final result is going to be here. F prime of x will be equal to 4x sine x plus 2x squared cos s. So I multiply this to this, and then I multiply this to this. So that is the product rule, very simple from there. Now let's look at this one. This is the change rule. So what I can do here is I can say that, okay, let my margin of x to be equal to cos of u. Then I can say that u is equal to x cubed plus 5x. Then it means that gen prime from here is going to be cos of, it's going to be minus sine u times u prime, because it's the change rule, right? Then I need u prime. So u prime from here is going to give us 3x squared plus 5. So this implies that gen prime is going to give us minus sine of u is x cubed plus 5x times u prime is, so I said anytime you put the dot here, make sure that whatever you are going to write, you put it in what? Parentheses. So this is what you are going to get. But you can also look at the function and just write it straight if you don't want to go through all the stress and you know how to do it. You can just look at it and say, okay, this is equal to this, and it is right. But sometimes trust yourself. If you trust yourself that you can do it that way, fine. But sometimes you might do it in your mind and maybe get something wrong. So it's good for you to use this approach and do it, and then you are done. Now let's look at this one. This one we are going to use the quotient rule. So I'm going to assign u to the top and v to the down. But I know that the quotient rule says that if I have this is the same as, I can say that u prime minus u v prime divided by v squared. So it means that if my u is equal to e to the power 3x and my v is equal to tangent of x plus 1, then I need u prime and v prime. So we know how to differentiate an exponential function. So I differentiate what is on the top, then I multiply it by the whole function. So when I differentiate 3x, I'm going to have 3, then I multiply it by the whole function. Now when I differentiate tangent of x, I'm going to get secant squared of x. Plus, when I differentiate to 1, I'm going to get 0. So that's what I'm going to get. So now my final result here is going to be, let's write it here. H prime of x will be equal to Vn is tangent of x plus 1 in parentheses, then times u prime, which is 3e 3x, minus I need u is e to the power 3x times y prime, which is secant squared of x, all divided by v squared, which is tangent of x plus 1 all squared. So this is what I'm going to get at the end of the day. So it's just knowing the formula here and knowing how to differentiate these functions. The rest is just substitution and you are done. let's look at this. So for me to differentiate this, as I said, some of the function we need to simplify before we differentiate. So I can write this one as 4x cubed plus 2 divided by x to the power 4 is the same as 2x to the power minus 4 plus square root of x is the same as 1 over 2. So now we can take the derivative for this. So let's do that. I will write the final results here, but let me do it step by step here so that you see what is happening here. So this is going to be 4 times 3 x to the power 3 minus 1 plus 2 minus 4 x to the power. So let me just put the parentheses here. Then minus 4 minus 1, then plus 6, 1 over 2 x to the power 1 over 2 minus 1. So I just wanted to do it step by step from there. So now let's simplify and put the results here. So this is going to give us 12x squared. Is it 12? Yes, 12x squared. Then minus 8x to the power minus 5. Yes. And then this is going to give us plus 3x to the power minus 1 over 2. So that's what we are going to get from this one. So 3 times 4 is 12. Subtract 1, you have the 2 minus this and that. Then you are done. It's just very simple from here. So derivative questions, you should be able to score everything for derivatives. Now let's look at this one. So a balloon is rising vertically at the rate of this, right? And the person is standing 80 feet from the launch. So let's assume that the balloon was somewhere here and it was going up. So it just moved up, right? This way. Or let me say, let me go this way. Let me see. Let me go this way. So the person is standing somewhere here, and we are saying that is standing 80 feet from where they launched it. So let's see that they launched it here. So it means that I'm going to have this, and I'm going to have this, and then the distance is 80. So anytime I'm solving Pythagoras theory, as soon as I know one side, and make sure that the other side are unknown so that I can use it to form the equation. So let me say this is x and this is y. So if that is true, then my equation is going to be 80 squared plus x squared is equal to y squared. So this is what I'm going to get using Pythagoras theory. Good. So now let me go ahead. Since we have assigned x to this, then it means that since the value is moving this up, then I'm going to have this here. So I'm going to have the x over the t to be equal to 5 feet per second, right? Because the value is moving vertically from here. Okay, so I think the launch should be here. Yep. And then this guy should be standing here. So the guy should be standing here. Good. So as soon as the balloon is moving up, his eyes will also be moving up. So that's the reason why we have this one here. Good. So I think this is right. Then let's see what we need again. So how fast is the distance between the person and then the balloon changing when the balloon is 50 feet in the air? So now this one is x is equal to 60 because this is where the balloon is. It's moving up. So we have x to be equal to 60 there. All right, so now let's try and then find a change. So let's differentiate this with respect to time. So d dt of 80 squared plus x squared is equal to d dt of y squared. So this is going to give us, when I differentiate a constant, I'm going to get 0. When I differentiate this with respect to time, I'm going to have 2x dx over dt. And then when I differentiate this, I'm going to have 2y dy dt. What are we looking for? We are looking for dy over dt, which is the distance between where the person is and where the value has reached. So that is basically what you are looking for. So now, because I'm looking for dy over dt, then this is equal to 2x divided by 2y dx over dt. When I divide 2 by 2y, and this is the same as x divided by y dx over dt. So now we have x, we have dx over dt, we need y. So for us to get y, we need to use the Pythagoras theory from here, the equation that we formed to solve for y. So since we know that x is equal to 60, then this is going to be, oh, okay, I think they've even given it to us. They said it's equal to 100, so we don't need to even calculate for that. So y is equal to 100 already given, because the question is saying that how far is the distance between the person and the balloon changing when the balloon is 60 feet in the air and the person and the balloon are 100 feet apart. So this is 100 feet. So we have this one as 100 already. So we don't need to compute anything from here. So now let's just do substitution and then we are done. So x is 60 and y is 100, and then the x over the t is 5. So let's try and simplify this. We are going to have, so just cancel this. 2 goes here 5, 2 goes here 3, 5 goes here 1, and goes here 1. So we are going to just have 3 feet per second. So that's what we are going to get from here. Yeah. So it's kind of very simple from here. Okay. Now let's look at question 4. Find the slope of the tangent to the curve. Okay. So now let's find the slope to the tangent. So we have 4x squared plus x squared y cubed is equal to 5y plus 8. So what we just need to know here is, now anytime we are finding the slope of the tangent line, we are differentiating the function with respect to x unless otherwise stated, right? So I'm going to differentiate this side with respect to x and differentiate this side too with respect to x. So now let's try and differentiate 4x squared. So when I differentiate 4x squared using the power rule, I'm going to have 8x plus. Now this we need to use the product rule because we have two functions. We have x squared and y to the power 3. So let me say that a is equal to x squared and b is equal to y cubed. Now what is a prime? A prime is 2x because we are differentiating it with respect to x. And then b prime will be equal to, using the power rule, I'm going to have 3y squared times change rule because we are differentiating with respect to x. So this one should be with dy over dx. So in the middle here, this, I'm going to multiply this by this and this by that. So I'm going to have 2x y to the power 3. So 2x y to the power 3. Then this time this is going to give us plus x squared times 3 y prime dy over dx. So as soon as I use the dot, I put it into parentheses, which is equal to. Now when I differentiate constant here, I'm going to get 0. When I differentiate y, I'm going to get dy over dx. So this will be 5 dy over dx. So as I said, since they've given us the point, we should just use it. So since we are dealing with slope, this is x and this is y. So we are going to have 8 times 1 plus 2 times 1 minus 1 to the power 3 plus 1 times 1 squared. Then this is 3 This is 3 minus 1 squared dy over dx, which is equal to 5 dy over dx. So let's simplify this. This is 8 minus 2, because minus 1 to the power 3 is minus, plus this is going to give us 1, 3, 1. So this is going to give us 3 dy over dx, which is equal to 5 dy over dx. Let's simplify this. So this will be 6, which is equal to 5 dy over dx minus 3 dy over dx. So I move this one here. Then this is finally going to give us 6 is equal to 2 dy over dx, and dy over dx. When I divide through by 2, I'm going to have 3 at the end. So the slope is 3. Okay. Now, don't forget, this slope that we have here, this one too can be written as f prime of 1. This is the same as f prime of 1, because this is the slope. So remember, when you are using the slope, we are thinking of f prime of x1, but x1 is 1. So this is also the same thing, so that we can use the idea from question 4 to solve question 5. So here the question needs us to write the equation of the tangent, but let me write this one here. This is y minus f of x1, which is equal to f prime of x1, then x minus x1. So as I said, anytime we are dealing with the equation of the tangents, the x and y value now changes to x1 and y1. So this is x1. So this is going to give us y minus f of 1, which is equal to f prime of 1, then x minus 1. So we've already computed this, which is 3. And then f of 1 is the same as the y1, the same as the y1. So this is going to give us y minus, okay, so they've given us f of 1 mu s, so we are not using this again because they've given us different function here. So I think we are not using this one here because they've given us f prime and they've given us this, so we don't need to use that one again. Okay, fine. So f of 1 is 2 and the slope is minus 3. Okay, so we are not using any information above. Okay, that's fine. I didn't check that, so we don't need to think about this, but this is true. What I did here is true. This is the same as f prime of 1, so that's true. So we don't need to do that though. So this is what you are going to get for the equation of the tangent with the information given here. All right, let's look at question 6. The distance in feet from the blue line stop of a student running to class t seconds after they start running is given by this. After how many seconds would their velocity be? 18 feet per second. Okay, so this one they've given us the velocity already. So here the velocity is equal to 18, and we know that velocity is equal to f prime, right, of t. So what we just need to do here is we need to differentiate this function, the position function here, to get the velocity, and then we equate it to 18, then we find for the time, because we are looking for the time. So let's do that. F prime of t is equal to, so this is our f of x, so this is going to give us 2t. Now the velocity, which is equal to f prime, is 18. So this is going to give us 18 is equal to 2t, and t should be equal to 9. So our 2 should be equal to 9. So we should be choosing this one here. Okay. Now let's look at question 6b. Suppose that f of x is continuous on this, and we have f of 1 to be this, f of 3 to be this, which of the following value of y is guaranteed to be the number of c between this and the, okay. So this is the intermediate value theorem. So we have c, which is in between -1 and 3. So the idea is that when I pick f of -1 and then I pick f of 3, when I pick f of c, that one is going to lie between here. So it's just the matter of multiplying through by f, which is not true, but for us to see this. So when I pick f of -1 and then I pick f of 3, when I pick f of c, this one should be c, it should also lie between the functions. Okay. So now f of -1 is 2, and then f of y is y, and then f of 3 is 7. So f of 1 is 2, f of c is y, and then f of 3 is 7. So the question is, we want the value of y, which is in between this. So the only value between 2 and 7 is 4. So pick this one here. So it's very simple using the intermediate value theorem. For which value of the constant c is f of s continuous? Okay, so if f of s is continuous, then the function, the limit exists, because since we are using less than or equal to there, it means that the limit from the left is the same as the limit from the right. So picking the limit, so limit as s is approaching 1 from the left of f of x should be the same as limit as s is approaching 1 from the right of f of x. So from the left is this one, and from the right is this one. So let's do it down quick. So limit as s is approaching 1 from the left, we are going to use cx plus 2, which is equal to limit as x is approaching 1 from the right. We are going to have 2 plus sine pi x. So now let's just plug it in. When I plug in 1 here, so I'm going to set x is equal to 1, set x is equal to 1 here. So I'm going to have c times 1 plus 2, which is equal to 2 plus sine pi. So this is c plus 2, which is equal to sine pi is 0. So I'm going to have 2 and oh, okay, this is minus. So this should be minus 2 from here, and this is also minus 2. So when I move this one, I'm going to have 2 plus 2, and this is 4. So c should be 4, so that the function will be continuous. Okay. Now let's look at D. So p of x is a profit function, and we want to approximate it, right? So anytime we are dealing with approximation, we are thinking of, let me say, if you don't know this one, we are thinking of the equation of the tangent, right? So you are thinking of something like the equation of the tangent. So the approximation for this one is going to be p of x is equal to p of x1 plus p prime of x1, then x minus x1. So you can relate this one to the equation of the tangent, right? Now, what is x here? X is what we want to approximate, which is 410. So x is 410. And then the x1 is what we have already in the function, which is 400. So x1 is 400. So it means that p of 410 is equal to p of 400 plus p prime of 400. Then x is 410 minus 400. So let's try and simplify this. P of 400 is equal to 900. So 900. Then p prime is 5. And then when you do the subtraction, this is going to be 10. So this is 900 plus 50. And this is going to give us 950. Right? When you add 900 plus 50 should be giving us 950. So that's what we are going to get for that one. And let's do the last one under question 6. Look at question 7 and we are done. So I can clean this one and use the place again. So now here we want to take the derivative of gene and then we look for gene prime of x. So let's use the change rule. Gene of x is equal to fx squared. So gene prime of x will be equal to, so the outer function is f, so we differentiate f, maintain x squared times, now you differentiate what is inside, what is x squared, and giving us 2x. Then now we are looking for gene prime of 3, so let's do direct substitution from here. We are going to have this one to be gene prime of 3 to be equal to gene prime of 3 squared times 2 times 3. So f prime 3 squared is 9 times 6. Now what is f prime of 9? F prime of 9 is 5. So we are going to have 5 times 6, and this is equal to 30. So we are going to have 30 here for our A. Okay, let's finish it by solving question 7, then we are done. Okay, so it's about sketching. So draw a graph of a function y is equal to f of x that is continuous everywhere except s is equal to 2. So s is equal to 2 is like a vertical asymptote because it's except, and that satisfies the rest of this. So since they're saying that except, then I can just 1 2 3 4 5 6 1 2 3 4 5 6. I can just put something here because this is my vertical asymptote before I can even start doing whatever I want to do. So I love this one because this one is easy to plot. So let me say this is -1. Okay, so I have -1, -2, -3, -4, -5, and -6. 1 2 3 4 -1, -2, -3, -4. So -1 is 1, so I can have it here. Let me use blue for that. Good. So that one is done. Now let's pay attention here. This function here is f prime. So we'll come and talk about it. Now let's look at this. This is a horizontal asymptote. As x is approaching infinity, the function is approaching 3. So it means that we are going to have a horizontal asymptote at 3 here. And as x is approaching infinity, right, we should be approaching 3. So we can have some line going this way. So we know that we'll be approaching that function there. So we are done with that one too. As x is approaching 2 from the positive side, we need to get to negative infinity. So this is 2, and this side is the positive side. So when we are approaching 2 from the positive side, we should be going to negative infinity. So we are going to have, let me use different color for this. Let me see. Okay, let me use this one. So we have this one. Then when I'm approaching this one too, I should be getting down here. Good. So we are also done with this one too. Now when we are approaching 2 from the left, we have -2. So when we are approaching this from the left, we need to get -2. So we can have it somewhere here open. And then we are approaching from this one. So let's have something like this. So we are done with this one. So now the only thing that we need to do is this functions here. Now this function here is saying that when x is less than -1. So when x is less than -1 here, these are the values. But this is f prime. So let's think of doing some integration here, right? Let's think about the function that when we differentiate, we are going to get 1. So I know that when I differentiate x, I'm going to get 1. So it means that as soon as I know that when I differentiate x, I'm going to get 1, then it means that from here, f of x is basically equal to x. Let's assume it that way, right? Without any constant. So this is my f of x. So if I want to plot f of x for x is less than -1, then I can pick -2. When x is -2, y2 will be -2. When x is -3, y2 will be -3. So now let's look at what is happening here. So I'm at this side, right, on the left. So when x is -2, y will be -2. So it means that I'm going to have it -2 -2. When it is -3, this one too will be -3, right? And in that order. So this is how the graph will be going. Okay. Now let's look at what is going to happen here. Then let me see what is happening when x is -1. Oh, am I doing it right? Let me see. Oh no. Yeah, I think I'm doing it right. Yeah. Let me see. -1 is 1. So -1 is 1. Okay. But I don't know. Okay. Let me just pause here. Let me look at the right hand side. I'll come there. Now the right hand side is this. So we are thinking of let me see, f prime, f of x should be -x. But I think because f of -1 is 1, then it means that there is a constant adding to this function. So it means that the function is basically adding 2 to the function. Yes. So this should be, since f of -1 is 1, then this one should be +2. Yes. Because if it is +2, then now we can see that when I plug in 1, so this is what is supposed to be. When I plug in x is equal to 1 here, I'm going to get 1, which is true. So this one should tell us that there was a constant adding to the function. So that now when x is -2, we are going to get 0. Okay. I think this is now right. So when x is this one, we are going to get that. Then when x is -3, we are going to get -1. Good. Then when it's -4, we are going to get -2 in that order. So the graph will be going down like this. Okay, I think that's right. Then I think definitely, since this is -1, this one too should be added plus, because now when I plug in -1, I'm going to have 1. So should I add +2 to this one too? Let me see if I add +2 to it, what is going to happen. So when I plug in -1, okay, this is basically going to be positive. So -1 here will be 1. Okay, so we don't need to add +2. So this one is just like that. Because when I plug in -1 here, minus will be positive. Okay, so it means that now -1 is 1. When I plug in 0, I'll get 0. Okay. When I plug in 1, I'll get -1, which is also going to be somewhere here. Okay, in that order till we get to this table. When I plug in -2, I'll get 0. So this one too should be this. Good. So now let me combine this graph here and then now explain the graph again. So this is going to give us something like this. Good, because this one was moving, approaching this, and this one was going down. Okay, so this is how the graph is going to look like. This is how the graph is going to look. Okay, so now let me try to explain most especially, I think this one here again. So here we are going to define the function based on this, right? Because when you plug it in, we should be having the function, because this one is direct substitution of the function. So this one, we know that since it's positive, we should have an x. But when I have x here and plug in -1, I'm going to get -1, which is not 1. So what should I do to -1 to get 1? +2. So that's the reason why this is +2. But here, when I plug in -1 here, I'm still getting 1. So I don't need to add anything to it. So I think that was how the function is. So the original f of x is this. Then the original f of x is also this. which is giving us this and that, and then we have the function of this. Yeah, so I think this is the end of the video.